Hello everyone. So today we will discuss about chemical properties of metals and non-metals. Metals or non-metals ka this is the second part, and in this part we will discuss chemical properties of metals, means reactions of metals. In metals and non-metal part 1, we have discussed about physical properties of metals and non-metals. So if you have not seen that video, then type on the YouTube metals and non-metals part 1 by Ruhul's tutorial, then you will get the video. Okay. So in this unit we will learn how metal react with air. Air means basically we will take oxygen. Reaction of metal with oxygen. Then we will study reaction of metal with water, then with dilute acid and with salt solution. So let us start. First one, reaction of metal with air. So first chemical property is reaction of metal with air. Air, basically we will take oxygen because oxygen is highly reactive. So generally oxygen react with almost all element. Generally it react with almost all element and form metal oxide. The general reaction is, if you react metal with oxygen, reaction of metal with oxygen, it will gives us metal oxide. Metal oxide. For example, suppose metal we have taken copper. Copper is a metal, react with oxygen, then what will be formed? Copper oxide. Aluminium is a metal, react with oxygen, what will be the product? Aluminium oxide. Now, what will be their formula? So, copper oxygen. See, copper have the valency 2, oxygen also have the valency 2. Formula is formed by exchanging of the valency. Now, if it is 2, it can be cut. So, this take ratio. 2:2 means 1:1. From 2 both are cancelled. What is the formula? CuO. So copper oxide have the formula CuO and it is of black color. It is also known as copper 2 oxide. Copper 2 oxide. Aluminium oxide, what will be the formula? Aluminium have the valency 3, oxygen have the valency 2. Oxygen having valency 2, aluminium having valency 3. Exchange it. What will be the formula? Al 2 times, O 3 times, in this way. So aluminium oxide having the formula Al2O3. In the same way, sodium react with oxygen, it forms sodium oxide. What is the valency of sodium? 1. What is the valency of oxygen? 2. What will be the formula? Na2O1. Na2O1. Okay. Same, potassium plus oxygen. What will be the formula? Potassium also have valency 1, oxygen 2. Formula will be K2O. Just cross the valency. So in this way metal oxide is formed, formula, by exchanging the valency. Now in this metal oxide, some metal oxide are water soluble. So in this many metal oxide are there. Some of them are water soluble and some of them are water insoluble. So those metal oxide which are soluble in water, they form alkali. So we can see that the metal oxide metal oxide formed is, if soluble in water, then they form alkali. Alkali means what? Water soluble base. Water soluble base. If it is soluble, if not soluble, then it will not form. So metal oxide form, if it is soluble in water, then it will form alkali, that is water soluble base. If it is not soluble, then it will not form. If it is soluble, then only. So we can say that further reaction can occur, means if metal oxide is dissolved in water, then it can form metal hydroxide. It can form metal hydroxide, which is a base. Metal hydroxide is a base. For example, sodium oxide, Na2O. So in sodium oxide, if you dissolve it in water, the sodium oxide, water is water soluble, and it dissolve in water to form sodium hydroxide, which is an alkali, water soluble base. Sodium hydroxide. In the same way, you can say the reaction with potassium. So potassium oxide, K2O, treated with water to form potassium hydroxide, KOH. Now you can balance it. Formula, how it is formed. So sodium, potassium have the valency 1. OH also have the valency 1. So sodium 1 time, OH 1 time, NaOH. That is the formula. Now sodium hydroxide, potassium hydroxide form. These are all alkali, water soluble base. Now balance. 2 sodium, take 2. Oxygen 2 time, oxygen 2 time, hydrogen 2, hydrogen 2. So this is the balance part. Now again, some metal oxide are there which behaves both as an acid as well as base. Like here, aluminium oxide form. This aluminium oxide, zinc oxide. So aluminium oxide, zinc oxide, these are the metal oxide which can behave as well as acid and base. They show both the properties of acid and base, and they are called amphoteric oxide. They are called as amphoteric oxide. So we can say that amphoteric oxide means those metal oxide which can react with both acid as well as base. Which can react with both acid as well as base are called amphoteric oxide. They are called as amphoteric oxide. For example, aluminium oxide, Al2O3, zinc oxide, ZnO. So aluminium oxide, zinc oxide, these are the examples of amphoteric oxide. Okay. Just now we have prepared aluminium oxide. So those metal oxide which react both as acid as well as base. Now what will be the product? Product will be to produce salt and water. To produce salt and water. Salt and water are called So those metal oxide which can react with both acid as well as base to produce, what will be in the product side? Salt and water. They are called amphoteric oxide. Let us take example, aluminium oxide, zinc oxide. Now reaction. So aluminium oxide, Al2O3, if you react this with HCl, what is HCl? Hydrochloric acid. So if the reaction occur with acid, this is acid, so this behave as a base. And if the reaction of this occur with base, like sodium hydroxide is a base, then it will act as a acid. Means it can react both as an acid as well as base. So acid plus base, salt plus water. So salt and water will be produced. Product will be salt and water. Now what will be the salt? See, aluminium, chlorine. The salt will form by the element aluminium and chlorine, and water will be there. So water, hydrogen and oxygen. So we know that acid plus base, salt and water, as written here also. Acid plus base gives you salt and water. Salt and water. So salt will be formed by aluminium and chlorine. So what will be the formula? Aluminium, what was the valency of aluminium? Just we have taken valency of aluminium is 3. Chlorine have the valency 1. What is the formula of the salt? Aluminium 1 time, chlorine 3 time. Aluminium 1 time, chlorine 3 time. And water will be formed. Water is fixed. Okay. Now balance it. How many oxygen? 3. Achha. How many aluminium? 2. Take 2. How many chlorine? 6. So 6. How many hydrogen? 6. 6. How many oxygen? 3. So it is 3. Okay. Now next reaction is this one. So let us try this. So salt and water will be formed. That is our product. Now what will be the salt? Formula of salt will be, see, aluminium, sodium and oxygen. So water will be oxygen, hydrogen. Hydrogen, oxygen will give us water. Okay. What will be the salt? Sodium, aluminium. Both are metal. And oxygen is there, non-metal. Metal, non-metal will give is salt. So sodium, aluminium, these are metals, and oxygen is a non-metal. So metal, non-metal give you what? Salt. So salt and water. Now balance. What will be the formula of salt? So sodium, aluminium. What is the valency? Sodium have 1, aluminium have 3. So total is 4. What is the non-metal? Oxygen. Oxygen have the valency 2. So metal have the valency sodium 1, aluminium 3 is a total 4. Oxygen is a non-metal having valency 2. Okay. So we have to take ratio. It can be cut by 2. So 2 is to 1. Now exchange. This how many times? 1. Oxygen how many times? 2. The formula will be NaAl 1 time, oxygen 2 time. NaAl 1 time, oxygen 2 time. So this will be the formula of the salt. Now balance it. Balance kar lo. For balancing, see, aluminium how many times? 2. So take aluminium 2. Sodium how many times? 2. Take sodium 2. Okay. Then hydrogen how many? 2. 2 is there. Oxygen 2 and 3 5. 4 1 5. So it is balanced. So now we have discussed that metal react with oxygen to produce metal oxide. Some metal oxide are soluble in water, they form alkali, and some metal oxide can react with both acid as well as base. They are called as amphoteric oxide. For example, aluminium oxide, zinc oxide. So how amphoteric? Means it can react with acid as well as base to produce salt and water, and formula will be decided by exchanging the valency. So now we will discuss different metals have different reactivity with oxygen. Different metals have different reactivity. Different metals show different reactivities toward oxygen. All the metal have not the same rate of reaction, not the same speed with oxygen. Some metal react very fast, some metal react very slow, and some metal also does not react with oxygen. Now let us see. First, potassium and sodium. Potassium and sodium are very highly reactive metals. They react with oxygen so vigorously, so speed is there, very much high speed is there, such that the product formed is catches fire. So potassium and sodium react so vigorously that they catch fire if they kept open. They will catch fire, so high speed is there. So in order to protect the fire and protect the metal, they are kept under kerosene oil. So this is the common question comes in exam. Why sodium or potassium are kept under kerosene oil? What will be the answer? Because they are very high reactive. They react with oxygen and catches fire. So in order to prevent them to catch fire, they are kept under kerosene oil. Second is, some metals are there like magnesium, aluminium, zinc and lead. They covered with a thin layer of oxide which protect the metal from further oxidation. Means what will happen? Magnesium, aluminium, zinc and lead. For this metal, they at the starting will react, but after that will not react. Means suppose you have taken aluminium is there, it react with oxygen to form aluminium oxide. So this aluminium oxide form will be around the surface. This surface will be covered with aluminium oxide, and this reaction will occur only at the surface. This reaction occur only at the surface, and bulk part will not react. So this aluminium oxide form will cover the metal from the surface, which prevent the further reaction, with oxygen. Means reaction will be there at the starting, and the product form will cover all the metals. The product form will cover all the metals from the surface, and then it prevent further reaction. So we can say that surface of the metal such as aluminium, maybe zinc, iron, lead, they are covered with their oxide, which prevent their further reaction. Iron does not react, but iron fillings react. We have seen iron kept in iron does not burn on heating. If you heat the iron, iron does not burn, but iron fillings does. Iron fillings will burn. Copper does not burn, but the hot metal is coated with a black layer of copper oxide. So copper metal also does not burn, but when it is hot, so at the hot position it react with oxygen to form copper oxide, as we have written already. copper plus oxygen, copper oxide. This copper oxide black colored, this one is black colored copper oxide. It coated the metal in the hot copper, not in the cold. And silver and gold, which is used by us as ornament, jewelry form, they does not react with oxygen. So this is the different metals have different reactivity toward oxygen. Some are very high reactive like potassium and sodium. Their reaction speed is so high that they catches fire. So they are not kept in open, because if you keep sodium in the atmosphere, in atmosphere oxygen is there, it react and produces fire. So it is kept under kerosene oil. Some metals are there which does not react with oxygen even after high temperature. Like silver and gold, they does not react with oxygen. Some metals are there which react a few, means little amount, and after that they does not react. Like this one, magnesium, aluminium, zinc, lead, they react at starting, after that reaction is stopped. Again, iron does not react, but iron fillings react. Copper does not react, but copper in hot state react and covered with a coating of copper oxide. So this is the reactivity of different metals with oxygen. So this was our first part, reaction of metal with oxygen. So next we will study reaction of metal with water. So our next topic is reaction of metal with water. So point number 2. Second number, reaction of metal with water. How metal react with water. Reaction of metals with water. Okay. So we know that metal react with water. So if metal react with water, so it can form metal oxide along with hydrogen gas. It will form metal oxide along with hydrogen gas, and that metal oxide, if it is soluble in water, then it will form metal hydroxide. Means there are two possibilities here. What are the possibilities? Product may be metal oxide or product may be metal hydroxide. So this will depend on the reactivity series. Reaction of metal with water is fully dependent on the reactivity series. So depending on the reactivity series and the hotness or coldness of water, we can predict the reaction. So first we have to know reactivity series. Okay. Reactivity series, earlier we have got which one is the most reactive metal? Potassium, sodium, then calcium, magnesium, aluminium, okay, then zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So if you remember the reactivity series, then it will be easy for us to predict the reactions with water. Now see, which one is the most reactive metal? Most reactive is potassium, then sodium. So reaction of sodium and potassium with water, this is what? This is the reactivity series. So reaction of sodium and potassium with water takes place. So water in this case is cold and reaction speed is very high. Reaction is vigorous and large amount of heat is produced. So metal react with water to produce metal oxide and hydrogen. If metal oxide is water soluble because we have enough water, so then final product will be metal hydroxide. So take the first two metal, potassium and sodium. So potassium react with water. What will be the product? Potassium react with water to form metal oxide, means potassium oxide and hydrogen. Again, potassium hydroxide is water soluble. They form metal hydroxide, potassium hydroxide. So final product will be KOH, potassium hydroxide. K having the valency 1, OH having the valency 1. In the same way, sodium is also having valency 1. So sodium react with water to form sodium hydroxide. Okay, balance it, and this metal hydroxide and other product will be hydrogen. Hydrogen gas will be evolved. Okay, balance it. After balancing, you will get how many hydrogen? 2, 1, 3. Here 2 is there. Take 2. 4 hydrogen. 4 hydrogen balance. 2 oxygen. 2 potassium. 2. In the same way, if you balance, this will be balancing part. So reaction of potassium and sodium with water takes place. In this case, you can take cold water. It is highly reactive with cold water. If reaction occur, then we can say that reaction of sodium and potassium with water is highly exothermic. It is highly exothermic and highly vigorous. Vigorous means very high speed and highly exothermic. Exothermic means large amount of heat is produced. So the hydrogen gas produced, catches fire immediately. So we can say that the reaction is highly exothermic, large amount of heat is produced and highly speed is there. So the heat production is so high that the hydrogen gas produced, they catches fire. So this is the reaction with sodium and potassium. Okay. Next is calcium. So if you take calcium, the reaction is not so much vigorous. Reaction will be there, calcium hydroxide will be there, but it will not catches fire. So we can say that calcium with water is less violent and heat produced is not sufficient for catching the fire. So we can say that reaction of calcium with water is less vigorous and it is also exothermic and heat produced is not sufficient for hydrogen to catch fire. Product will be same. Calcium plus water, calcium hydroxide and hydrogen. So first step will be what? Calcium plus water, metal oxide and hydrogen. So calcium oxide and hydrogen. Second step is metal oxide plus water, metal hydroxide. So calcium oxide plus water, calcium hydroxide, because it is water soluble. So we will write the final statement. Final is calcium plus water. Here also you can take cold water, no problem. Cold water is there. Product will be what? Calcium hydroxide. Now what will be the formula of calcium hydroxide? Let us check. Calcium hydroxide and hydrogen gas. What is the valency of calcium? 2. What is the valency of OH? 1. Formula will be calcium 1 time, OH 2 time. Calcium 1 time, OH 2 time. So it is also exothermic. So here heat production will be there, but not so much heat is produced that hydrogen gas will catch fire. Now in this case what will happen? Hydrogen gas formed will stick on the surface of calcium metal, and this metal will start floating. So we can say that hydrogen gas produced this stick on the surface of calcium, and metal, and calcium metal starts floating. This will start floating. So this is the information about calcium with water. So we can say that calcium react with cold water, but the reaction is not so much exothermic that hydrogen gas produced catches fire. Reaction is this one, you can balance it, and the hydrogen gas produced in this case will stick on the surface of calcium, and this will start floating. Okay. So this is the reactivity series. If you go above, the reactivity increases. If you go above, then reactivity increases. So highly reactive is potassium, then sodium, and then. Okay. This is the increasing order of reactivity. Increasing reactivity means above metals are more reactive, below metals are less reactive. Now next is magnesium. So what about the reaction of magnesium with water? What about the reaction of magnesium with water? So we can say that magnesium does not react with cold water. Magnesium does not react with cold water. It reacts with hot water to produce magnesium hydroxide and hydrogen. So first point of difference is that magnesium does not react. It does not react with cold water. It reacts only with hot water. It reacts only with hot water to produce. What will be the product? Product is same, magnesium hydroxide, to produce magnesium hydroxide and hydrogen gas. Now write the reaction. So magnesium react with hot water. This time water will be hot. Product will be magnesium hydroxide along with hydrogen. Now you can balance this one. Magnesium have the valency 2. Magnesium have the valency 2. OH have the valency 1. Just cross it. In this case also hydrogen gas produced will stick on the surface of metal and the metal will start floating. So in this case also hydrogen gas produced will stick on the surface of magnesium, and magnesium metal means metal will start floating. So this is the reaction with magnesium. So these three react with cold water, this react with hot water. Next, aluminium, zinc, iron. Aluminium, zinc, iron, they neither react with cold water nor react with hot water. They react with steam, means more heat is required. Aluminium, zinc, iron does not react with cold water as well as hot water, they react with steam. So next we can say that aluminium, zinc, iron, they neither react with cold water nor react with hot water. So it neither react with cold water nor react with hot water. It react with steam. It reacts with steam. It reacts with steam. And what is the product? To produce. Now here product is different. So we have got potassium, sodium, calcium, magnesium. In this case, metal hydroxide. Metal hydroxide and hydrogen gas. But in case of these three, metal oxide and hydrogen gases are produced. To produce metal oxide, not hydroxide, metal oxide and hydrogen gas are produced. Now check the reaction. So if you take aluminium, reaction of aluminium with water, what will be the product? Metal oxide. So aluminium is metal, oxygen is oxide. So at the starting we have got the formula of aluminium oxide, Al2O3. Aluminium valency 3, oxygen valency 2, and hydrogen gas will produce. Now balance it. How many aluminium? 2. How many oxygen? 3. How many hydrogen? 6. Again, if you take iron, so iron react with iron, Fe. So writing here, iron react with water to produce metal oxide, Fe3O4. Fe3O4 iron oxide along with hydrogen gas. So aluminium reaction is this, iron reaction is this one. Now you can balance 3 iron, 4 oxygen, 4, 8 hydrogen, 8 hydrogen. In the same way, you can write the reaction with this zinc. So same reaction type will be there. So metal like aluminium, zinc, iron, they react with steam. They does not react with cold water or hot water, and their product is aluminium oxide and hydrogen gas. Now, and the last, lead, copper, silver, gold, they does not react with water. So now lead, Pb means lead, then you can say copper, this silver, gold. This gold Au does not react with water. They does not react with water. So this is the reactivity of metal with water. So we have got different reactivity of metals with different forms of water. Okay, so once check from starting this one. What is reactivity series? Reactivity series means metals are arranged on the basis of their reactivity. So metals are arranged on the order of their reactivity. This is called reactivity series. Okay. So reactivity series means metals are arranged in order of their reactivity, known as reactivity series. So what we have got, this is the reactivity series. Above one is highly reactive and lower one is the least reactive. So this reactivity series, we have got these metals, this up to magnesium, they form means potassium, sodium, calcium and magnesium, they react with water to form metal hydroxide. They form metal hydroxide. And aluminium, zinc, iron, they react with water. To form metal oxide. And rest one does not react with water. So lead, copper, silver, gold, this plus water, there will be no reaction. Again, water, their format is different for different metals. These three react with cold water. Magnesium react with hot water, and these three react with steam. And this do neither react with water. So we have written the reaction of aluminium and iron with water. So below there you can write steam. So this is the second reaction of metal. First we got oxygen, second with water. Now third reaction of metal is with dilute acid. So now we will discuss the reaction of metal with dilute acid. Okay. Third one is metal plus dilute acid. This will give us salt and hydrogen gas. Salt and hydrogen gas will be produced. So when metal react with dilute acid, product will be salt and hydrogen gas. So let us take some examples. For this. So from starting now today only we have written some reactions, like reaction of aluminium with dilute acid. We have written in the amphoteric nature of aluminium oxide there. What will be the product? Salt and hydrogen. What is the formula of hydrogen? H2. What will be the salt? Aluminium having valency 3, chlorine having valency 1. The formula will be Al 1 time, chlorine 3 time. Al 1 time, chlorine 3 time. Now you can balance it, 3 chlorine. So take here 6 will be then 3, 6 and 2 aluminium. Balance. In the same way, if you take metal plus dilute acid, dilute hydrochloric acid, salt and hydrogen gas. So H2, what is salt? FeCl2. iron 2 chloride. Iron valency 2, chlorine valency 1, just exchange it. You can take another acid also. Suppose you have taken zinc and dilute sulfuric acid. What will be the product? Hydrogen gas is formed along with ZnSO4, zinc sulfate. So if reaction of metal takes place with acid, product will be salt and hydrogen gas. Okay. Now, if you take nitric acid, then what will happen? If you take, suppose zinc, you have taken nitric acid, HNO3, dilute nitric acid. Now, product will be what? ZnNO3 zinc nitrate, ZnNO3 whole 2, and hydrogen gas will be there, H2. What is the formula of zinc nitrate? You see, zinc having valency 2 and sulfate having valency 2. What is the formula? This ratio, 1, 1. So ZnSO4, zinc sulfate, zinc nitrate, Zn valency 2, nitrate valency 1. What is the formula? Zn 1 times NO3 2 times, Zn 1 times NO3 2 times. So reaction of metal with dilute acid gives us salt and hydrogen. So it is okay with HCl, no problem. HCl, no problem. Sulfuric acid also okay. But if you take nitric acid, then there will be some problem. If you take nitric acid, then what will happen? The product is not hydrogen. The product will be not hydrogen gas. Why? Because nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. It will oxidize the hydrogen gas produced into water and self will convert into nitrogen oxide. It may be NO, it may be N2O, it may be NO2. But in this case, product is NO. So here the product hydrogen is formed, so it will be oxidized by nitric acid into water and NO. Into water and NO. So product will be water and NO. Now you can balance. After balancing, whatever be the number, that will be our answer. So we can say that in dilute nitric acid, dilute HNO3, HNO3 means nitric acid. Dilute nitric acid is a strong oxidizing agent. It is a strong oxidizing agent. So hydrogen gas produced, will be oxidized to water and HNO3 self decomposed to give NO या NO2 या N2O. So generally NO2 is formed with concentrated nitric acid. So this or this. NO or N2O with zinc, the product is NO. So copper, if you take, then NO will be the copper plus nitric acid, dilute. So what will be the product? Salt. Copper, nitrate. So copper have the valency 2, nitrate have the valency 1. So exchange formula will be copper 1, nitrate 2. So this will be copper 1, NO3 whole 2. Now and hydrogen gas. But it is a strong oxidizing agent. So hydrogen gas produced will be oxidized NO. So this is the reaction of copper with dilute nitric acid. It will give copper nitrate and hydrogen. Since it is a strong oxidizing agent, so hydrogen gas produced will be oxidized to water and NO. So this is our reaction number 3, reaction of metal with dilute acid. Only difference is in case of dilute nitric acid. Now fourth number reaction is reaction number 4 of metal. So metal, suppose there are two metals, metal A plus salt solution of metal B. Salt solution of metal B, then it will gives us product metal B plus salt solution of metal A. Means there will be displacement reaction. So you can say simply it is displacement reaction. So this is the fourth reaction of this one, metal A plus salt solution of metal B. What will be the product? Metal B and salt solution of metal A. So this we have studied in lesson number 1, chemical reactions and equation, displacement reaction. So this is the displacement reaction. Now let us take one example. Displacement reaction. So displacement means highly reactive metal will displace less reactive metal. Okay. So suppose we have taken one example, zinc. If you react zinc with copper sulfate, so zinc is what? Solid. Copper sulfate is solid. Give it in water. If you dissolve copper sulfate in water, then it will produce a solution. So since zinc is more reactive than copper, zinc is more reactive than copper. So if zinc is more reactive than copper, then zinc will displace copper. Also we have discussed it. Zinc will displace copper. See here, this is the reactivity series. If you go above, reactivity increases. Zinc is more reactive than copper. Zinc is above, more reactive. So zinc will displace copper and zinc sulfate will form. Copper will be eliminated. In place of copper, zinc will come. So copper solid and zinc sulfate aqueous. So this is the reaction. Now if you write copper plus zinc sulfate, what will be the product? So copper is less reactive than zinc. Since copper is less reactive than zinc, so copper will not displace zinc. So there will be no reaction. Since copper is less reactive than zinc, so copper is unable to displace zinc. So this is already explained by me. So you can type on YouTube displacement reaction and double displacement reaction, both are there by Ruhul's tutorial, then you will get the video. Take one more example for this. If you take copper with silver nitrate solution, copper metal, silver nitrate in water, it will give a solution. What will be the product? Since copper is more reactive than silver, so copper will displace silver. So silver is eliminated. So silver solid is formed, and in place of silver what will come? copper. So copper nitrate will be formed. CuNO3O2. So take 2 times, it will be balanced. So in this way displacement reaction are there. If you react silver plus copper nitrate, then no reaction since silver is less reactive than copper. So in this way you can form the reaction. Take one more example for this. Suppose you have taken iron solid, this you take in copper sulfate solution, then what will happen? Iron is more reactive than copper, so iron will displace copper, so copper will be there and iron will come in place of copper, so FeSO4 in water, this will form. So this will form in water aqueous. So this is all about displacement reaction. So displacement reaction fully depends upon the reactivity series. If you learn the reactivity series, if it is remembered, then it is easy. And again, reactivity of metal with water is also fully dependent on reactivity series. So some short tricks are there to remember the reactivity series. Although it is explained in the first lesson, so again I am writing that part. So it will be revised once also. So reactivity series we got is this. If you go above, then reactivity increases. Okay. So first potassium, sodium, calcium, magnesium, aluminium, zinc. The short trick is that please. So P4 potassium, please stop calling me a zebra. Please stop calling me a zebra. So from this P4 potassium, S for sodium, Ca for calcium, M for magnesium, A for aluminium, Z for zinc. So P for potassium, S for sodium, Ca calcium, M for magnesium, A aluminium, Z for zinc. Then I like her calling my sweet girl. So I like her calling my sweet girl means I for iron, L for lead, then H for hydrogen, C for copper, M for mercury, S for silver, G for gold. So by this trick you can easily remember this reactivity series, and if you go above, then what will happen? Reactivity increases. Reactivity increases. Which one is the most reactive? Potassium. Potassium is the most reactive element. It is the most reactive element. So this trick you remember, it is easy. Please stop calling me a zebra. I like her calling my sweet girl. So sodium, potassium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, gold. So this is the chemical properties of metals. In our next video we will discuss reaction of metal with non-metal. So there we will get ionic bond or electrovalent bond. Okay. If any confusion, doubt is there, you can ask me in the comment section. Thank you.